The service station is a staple of America's love affair with the automobile. Now it's going away as the rise of electric vehicles and e-mobility takes over for internal combustion engines. How will this transition affect car culture, and what's involved with onboard charging? How can we invert a process that's over 100 years old? One little linchpin of the entire process is the gate driver, which helps to make residential charging possible in the fast-growing sector of electric vehicles. Imagine a world where the ritual of visiting the gas station on the corner to refuel your vehicle becomes a distant memory, replaced by the convenience and comfort of charging your electric car in the sanctuary of your own home. This is the world of residential electric vehicle charging, a revolution that promises to transform not only the way we power our vehicles, but also the very nature of our relationship with transportation. At the heart of this transformation lies the onboard charger, a marvel of modern engineering that allows your vehicle to accept the 110 or 220 volts of electricity that flow through your home. But the true unsung hero of this story is the gate driver, a device capable of operating in astonishing high voltage environments like 400 to 800 volts, converting power through wide band gap technologies like silicon carbide to maximize the efficiency of residential electricity for your vehicle. Recent news stories have highlighted the growing trend of onboard charging and the profound impact it is having on our daily lives. No longer bound by the need to visit a service station, we find ourselves free to reimagine the way we use transportation, from the daily commute to long-distance travel. As we embrace this new era of electric mobility, we face challenges in adapting our infrastructure to meet the growing demand for power. But with each passing day, the pace of innovation accelerates, bringing us closer to a future where the efficiency and convenience of residential charging becomes the norm, thanks to the unsung heroes like the gate driver that make it all possible. How can Microchip technology help maintain our love affair with the automobile as we transition to an electric future? Let's go beyond the Microchip and hear a story of empowering innovation to enhance the human experience. Our guest today is Jeff Garcia. Jeff is a product line marketing manager at Microchip Technology, working out of the Analog, Power, and Interface Devices business unit. He joins us today from our global headquarters in Chandler, Arizona. Welcome, Jeff. Thank you for joining us on Beyond the Microchip.
Thanks for having me.
In the intro, we briefly talked about the humble gas station that's been a staple of automobile ownership for over 100 years and how the evolution of electric vehicles could fundamentally change our love affair with the automobile. That is to say, we may not need gas stations in the very near future if we can just refuel at home. Tell us about it.
Yeah, no, that seems to be kind of something potentially that we'll be heading towards in our future. Myself, I actually kind of experienced this. For a while, I was making a commute and I had an electric vehicle for myself. And I almost forgot what I needed to do when I went to the gas station because I wasn't pulling up any longer to fill up the gas, right? I was maybe going out to get a drink and then just be on my way, back home or pick up some snacks for the family. So it was kind of an interesting transition because I could wake up in the morning and have my vehicle ready to go. And not, again, very rarely visiting a gas station as I typically would with a gas powered vehicle. It was kind of an interesting experience. And, I look forward to having my next electric vehicle because of that. Just the lack of dependency on something outside, right? Sometimes we've had issues where gas maybe became a little bit more scarce or price fluctuations.
Price fluctuation, right?
Right. And so kind of being able to take that on into yourself and your own environment, like as you mentioned in our homes, it was kind of an empowering experience. And it also just, in my mind as an engineer, it was kind of interesting to say like, wow, I can actually just power my own vehicle from home and be on my way. So it was quite an interesting transition we've made as we progress in the electrification of our vehicles.
Right. So the service station is kind of, I think everybody can relate to the being in a hurry to go somewhere. You get out to the car, you turn it on, and you realize I'm out of gas, which really isn't that much of a problem if you have charging at home or charging where you live. But I was interested that there's got to be 3, 4, maybe even 5 different charging plugs that you can get with different electric vehicles. But that doesn't really change how the charging process works.
That's right.
Other than the voltage?
Right. Yeah. It's one of the probably leading U.S. car manufacturers has kind of dominated that space. But again, you're not limited to that type of plug. And the industry are trying to merge to a standardized plug. So customers don't have that experience. I mean, we experienced that with consumer electronics. If you're maybe an iPhone user or a non-iPhone user, maybe only till recently that was a challenge. You had a specific plug for that iPhone.
You need
right?
an adapter, right?
Right, and that's been the case. That's been kind of like a transition that they've done for EV vehicles today. But again, they're kind of transitioning to more of a common standard platform, and that's both in the U.S. as well as in globally. The European market is leading that as well, trying to have a standardized plug as well. So I think that's going to go away. But to your point, yes, I mean, it doesn't really matter. Those are just different formats that maybe the car manufacturer had decided upon. And then just as standards are being developed and put in place, whether it's the voltage that you're applying to the vehicle or any of the safety considerations there, I think we'll find that we'll kind of have a standard format eventually in a not too far future.
Right. So I have a plug-in hybrid that's got one specific kind of plug, like we were just talking about. And when I first got it, I hadn't done the conversion at my house yet. So I had to plug into the regular 110 volt. And obviously it took 16 hours to charge the car. But then I got an electrician in. The electrician put in a 20 amp for, I guess, phase 2. It's not super fast charging. I know that. It takes about 3 hours to charge my car now. And so he changed the plug on the wall. I had to get an adapter, but the same plug goes into the car. And so regardless of what happens in the conversion process, that's still the same apparatus on the vehicle. I didn't have to change anything on the vehicle. Is that common to have that infrastructure?
Yeah, I think as a OEM or a car manufacturer, I think they wanted to have the convenience of, if you're in a situation that you initially only had 120 volt or 110 volt outlet available, they still wanted to have it, access for you to charge a vehicle. And you also think about that even outside of your home. So if you're traveling or maybe you went to a friend's house and you needed to charge a vehicle, you can't count on them having a high current charging plug in your residence there. So yeah, they needed to make that capable to support either 120 or 240 type outlets. So that's where the electronics come in. The onboard charger is handling that kind of aspect of the vehicle. And we'll touch on that, I think, later on in our talk. But it's a convenience factor, right? I mean, if you're stuck and you only have a 220 volt plug, you're going to be limited to where you can charge your vehicle. So again, I think it's for a user experience as well as just making sure you do have access to the ability to charge your vehicle.
Right. So we need to be able to recharge wherever with whatever power source is available.
Right.
So let's talk about long distance traveling in time to charge. Those are fairly significant concerns, right? So we're talking about the gas station. The gas station, you roll up, you pump a liquid into your car with an internal combustion engine. You're probably in and out 5 minutes, maybe 10 if you got a pretty large vehicle, but you're still looking at a very small time commitment. You talked about getting a drink. Just enough time to go in, grab a snack, and get back out, and you're on your way. Whereas charging, even in the case of my setup, it's still a couple hours to get charged, and I have a very limited range because it's a hybrid. So when we're talking about long distance traveling and time to charge, what can we do to improve charge time?
That's a big concern in the industry. There's a term range anxiety that people have, right? And I think if you're like someone that's going to be on the road quite a bit using your vehicle, that is a very valid concern. If you're trying to get somewhere in a shorter period of time, like you mentioned with a standard ICE or combustion vehicle, you're filling your gas 20 minutes or 15 minutes and you're on your way. With charging vehicles, there's a lot of challenges. It's what power is available when you get there to, like, say, charging station. How fast can your vehicle actually charge? And that is actually kind of limited by your onboard charger. So that kind of dictates how much power can be delivered to the battery. And there's also the battery technologies that we're currently exposed to. They can only be charged so quickly without damaging them. So that's one trade-off. The industry's made quite a significant improvement in that, in the fact that you can charge a battery faster and you can still and you don't degrade the behavior of the battery or how much charge you can actually put into it. So, but yeah, it's a challenge because, people I think when they put it on paper, like, oh man, it's 30 minutes, so I got to be waiting to do a fast charge, right? And that in this big scheme of things, it's probably not that bad because you could probably, maybe if you're on a long distance trip, you're going to stop, maybe eat anyway. Right. And so you can plug your vehicle in, get your vehicle there. But yeah, with an onboard charger, that can help you get your vehicle charged faster, right? And so the industries are trying to get onboard chargers to be capable of charging higher in energy and to basically shorten the time of the vehicle at the charging stations. Yeah, it's interesting. I mean, it's one thing I think it's the only really challenge actually is when you do a long distance travel. But if you put in perspective and you wake up with your car every morning when you're just having your daily commute, I mean, your car is basically a full tank of gas every morning.
Ready to go.
And I don't think people really put that in perspective until they, actually experience it on their own.
Yeah, that's going to take something to deal with. There is probably still the convenience of charge for a little bit to get a little bit of range. That's kind of the equivalent of put $5 in, for the internal combustion engine.
Right.
I think you're right. You're running into a scenario of a road trip. And if you're planning a road trip without stopping, probably not going to be that exciting of a road trip. But that's probably just something you have to take into account. Now, you have to stop. You have to allow the batteries to completely come up. So what happens to the battery over time? If we're talking about increasing the amount of power in and out of a battery, what will that do to the battery?
Unfortunately, like most things, they will start to degrade. And,
Right.
And there's industry that is focused strictly on improving battery integrity and robustness. Not something that we necessarily worry about as Microchip, but we make sure that we have solutions that can enable charging vehicles sufficiently. But yeah, unfortunately, there's here being based in Arizona, heat is not a friend to batteries.
Right.
The vehicle I had was one of the first generation batteries, and it didn't come with a cooling system to maintain the temperature of the battery pack. And that was a big challenge for that manufacturer, actually. So they actually started, having to replace vehicle batteries under warranty that was unanticipated because of the extreme heat that Arizona has compared to the rest of the parts of the world. And so, yeah, that unfortunately, there's many things, charge cycles. So how many times you charge the vehicle, and then also the heat, even cold can be a detriment to that. So in fact, a lot of vehicles, if they have enough intelligence in it, when they know you're going to go start charging your vehicle at like a higher or fast charging station, they actually will start preheating the battery because it needs to be at a certain temperature to be the most optimal charging experience.
Right.
There's a lot of things that maybe as a user is not known because the electronics are being managed, by the manufacturer's conditions that they put into the system, right? So, but yeah, unfortunately, like anything, a battery will start to degrade over time, and then you end up with maybe lower and shorter distance capabilities. So I think that I'm hoping that's something that's just a short-term challenge that we're facing based on what kind of battery chemistries we're using and approaches we're taking. And the ultimate goal would be if you had a battery that could charge and hold a lot of energy, charge quickly, and be very robust, right? So you don't have to replace it quite as frequently, right?
Right. Yeah. And you're hoping that the automotive manufacturers catch up.
Yeah.
When I came out to Arizona, I may be remembering this wrong, but when I came out to Arizona, it seemed like the battery in my car just died. It was a 12 volt. It didn't have an intercooling system. It was a standard 12 volt battery, something you'd get at a hardware store. And I said, I got to get a new battery. And he said, pay attention to the warranty. I said, what do you mean? He says, don't get a 3-year, get a 5-year. I said, all right, well, before I came to California, it was like, well, the battery will last as long as the car does. And he's like, no, it won't. And so his whole scheme is in Arizona, we know that batteries go quickly because they don't have these protections in place. They don't have cooling systems. So if you're in Arizona, get a 5-year battery because the warranty will probably keep your battery going forever. Anyway, that's an internal combustion engine.
Yeah.
That got me thinking about it because I want to get back to cycle times. Will this improve the cycle time of the battery?
Well, with with the progression of the battery technologies, but then also with onboard charging, as we progress to go to higher power capability. So you can kind of think as an onboard charger as basically as a cell phone charger that you have at home, and you can buy different ones, right? And maybe people may not be aware of that. Sometimes you can see it says 15-watt charger or 120-watt charger. And this is the exact same thing with an onboard charger. There are power limitations to that. So I think the most common found onboard chargers typically about 11 kilowatts.
Okay.
And then there's a push to go higher power, so up to 22 kilowatts.
Right.
So again, higher power just means faster charging to the vehicle's battery. So that's kind of where we're trying to improve the downtime of when you need to charge a vehicle, get back onto your destination. Microchip offers quite a few solutions from the controlling aspect of that charging. We also offer wide band gap technologies like silicon carbide.
Mm-hmm.
In order to even leverage silicon carbide, they do require a specific type of driving a device or a gate driver, and that's where our product comes in that I support. So with a silicon carbide specific gate driver, this is helping enable those faster charging experiences that you can see as we approach higher and higher power levels.
Yeah, so let's get into that. Let's get into the gate driver.
Sure. Yeah, silicon carbide or even GaN, those are fairly newer technologies that have been adopted in probably the last 5-6 years very aggressively. Silicon carbide has been in the industry for decades, but it's not been really gotten more commercialized into more familiar applications that we know today. Electric vehicles have pushed that adoption very quickly. Most electric vehicles in the past might have been using IGBTs because those at the time were a more common use, high voltage switching device.
And those have been around longer.
Right. And they're very robust. I mean, there are some advantages to IGBTs, but again, with silicon carbide, it's a wide band gap technology. So basically it allows you to have a more efficient switch in your system. And they can withstand much higher voltages compared to IGBTs or even GaN.
Right.
The higher voltage really brings the benefit of improved power delivery. So with power being current times voltage, if we can increase the voltage, then that means we can actually reduce the current in the system. And that translates to lower or smaller cabling in the vehicle, more efficient systems because you don't have as much losses in your system typically. So again, to leverage silicon carbide, however, we need to be able to drive or turn on the device efficiently. And that's with basically a silicon carbide gate driver. And because these are used in high voltage environments, as you mentioned earlier, like with an EV, there's typically 400 volts or now 800 volt batteries. And again, they're going to higher voltage batteries because of the efficiency gains that they can have on that.
Yeah, because you can charge them now.
With a gate driver, we need to have a device that can be both in a low voltage environment because what's driving the gate driver is the controller, like a microcontroller from Microchip that would maybe like a 5 or 3 volt environment. And then it's going to be powering or turning on the gate of the silicon carbide, which is now in an 800 volt, environment. So our approach with a gate driver was an isolated gate driver. And what that does allows you to basically have a low voltage signal go into the driver, and then it outputs a higher voltage, or the secondary outside of the output of the gate driver is exposed to a higher voltage environment. And internally, the device is isolated. So there's actually no voltage or current being applied between the input and the output of the device. And we've done that through our capacitive isolation approach. It's not new to the industry, but it was the approach that Microchip decided to go with when implementing our isolated gate driver.
Right. Okay. So we talked about gate drivers. Microcontrollers have a lot of capabilities, right? But will you find that you have enough power to turn on and off higher power discrete devices?
Yeah, and I should have mentioned that earlier before. Yeah, that's where even a gate driver, whether it's driving a MOSFET, a silicon carbide, or IGBT, that's where a gate driver comes into place. Microcontrollers, they're great. They can do multiple functions and perform many actions, but they just don't have a lot of output capability to drive a power switch. And then what the gate driver does is actually takes that low signal output from a controller and then actually boosts it or amplifies it to drive a gate of a given output power switch, which could again be silicon carbide or GaN or IGBTs, for example.
So we got a lot of power coming in. It's got to get converted and reconverted up and down accordingly as part of the electrical system. Right. Okay, so which devices apply to the applications we've been talking about?
With onboard charging, silicon carbide has been kind of the predominant use case for getting the more efficient output of the onboard charger. So whether you're trying to increase the efficiency or support higher voltage environments like the 800 volt that we've talked about, so you'll find that there's multiple silicon carbide FETs in the onboard charger. And again, in order to power those devices or turn them on and off, you need the gate driver to be part of that equation. So, for Microchip, we'll offer the controller that's managing the onboard charger functionality, and then the gate driver will then translate that control signal to the silicon carbide MOSFETs that are being implemented there. And you'll see a lot of times, silicon carbide, it'll probably be at least, I'm guessing right now, I think about 22 FETs in an onboard charger today. And that could be also seen as modules too. So it could be reduced because there's more die in a MOSFET module. But in general, there's quite a few silicon carbide FETs in parallel that are allowing you to improve this output efficiency that you have in the system.
So suppose one of our listeners has a use case for this technology. Where would they go? Where could we send them?
Our landing page for Microchip, we have a segment or a section called Power Management. And then under there, you'll find a section called Gate Drivers. And within there, you'll see our large offering of gate drivers that we have. Silicon carbide is a newer product family that we've added to the existing portfolio, but we do also have a pretty long heritage of gate drivers that Microchip has acquired through acquisitions. Yeah, so the last 10 years we acquired Micro. Another acquisition, I believe, was done in 2006, which was telecom.
Mm-hmm.
And so we have both those product families still in the portfolio. And then we've continued to grow that based on solutions that need to be met by our clients, as well as isolated gate driver family, which is newer to the portfolio.
Right. So you brought up an interesting point. We've got the microcontroller, we've got the gate driver, we've got the discretes, we've got the silicon carbide. We're kind of piecing together these either through acquisition or through internal innovation to get to that kind of total system solution concept that we're talking about, where we provide as much as we can for a complete electrical system. With that in mind, let's talk about predictions. So onboard charging, gate drivers, silicon carbide, we're talking about upgrading to 11 kilovolts, 22 kilovolts.
11 kilowatts, and we're going up to 22 kilowatts.
22 kilowatts.
Right.
So we're seeing a trend line of an increase in the amount of power that we're moving through. So what kind of predictions do we have for the future?
I guess everyone would wish to have their crystal ball. As managing a product line, we try to identify where the industry trends are going and to make sure we're putting our resources in the right areas to make sure that we're right where we need to be when the customers or clients are looking for solutions. So, yeah, I think it'll be interesting to see how the transition occurs. I think there was a lot of hesitation with EVs in general from customers. I think they like the comfort of knowing that they're not dependent on a battery to be charged all the time. You see a lot of challenges with environments like we mentioned here in Arizona being very hot, and then there's also parts of the country or in the globe that are very cold, and that's brought some other challenges as well.
Yep. Yeah, because the battery's got to operate within a range, right?
Exactly, right. And I think it's going to be interesting. I mean, I think onboard charger will mean a very critical piece of an EV, right? I mean, because you're not always going to have access to a fast charger when you're traveling or in your home. So, you'll be stuck on having to use your wall, outlet, like you mentioned before, you had 110 before, and then you converted maybe to 220 to get a higher, capability. You
got to go where the power is, right?
Exactly. So, and that whole chain is dependent on the onboard charger in your vehicle. I think there's been talks about trying to get an onboard charger out of the vehicle at some point, but the infrastructure for charging is not there yet to even consider that at this point. But that would be kind of like maybe the holy grail of, from an OEM standpoint, they could take that kind of heavy piece of electronic out of the vehicle. But in the meantime, I think there's some interesting things. A lot of people don't like having to plug their car in.
Oh yeah, we didn't even get into that.
Yeah. It's interesting because it is, if you have like a smaller garage and you got to find your, park it in the garage and then plug it in and see if you have enough space for that, and that can be kind of just more of a nuisance than a problem, but it's just something that people don't like to do.
Right.
But also, like, if you may say pull up to like a regular parking lot, it would be great if you could just park your car and then your car just starts charging, right? And so,
like a wireless pad?
Exactly, yeah. And, that's been talked about for many years. I remember I was at a CES, probably like I think 2008 or 2007, and there were some tier ones that were making this proposal where they could have a charging pad on the ground, and you just pull your car over on top of that, and it starts charging just like we do today with our phones today, right? Yeah. So I think that may have some potential, long term, because again, if you can imagine just pulling into a parking lot while you go shopping and your car's charging, when you don't have to go up to a kiosk and get the plug out of the kiosk, and hopefully it comes out. I've seen that before where people go to a charging station, they can't even get the plug out of the system because the charging station's not working, right?
Right, yeah.
Not to say that maybe prevent that, but at least it would be an option. They could just pull their car in and their vehicle starts charging, right?
Well, it lends itself to people that don't have garages, too. If there's an opportunity to have something like that on the street, or if there's an opportunity to have that in a driveway.
Yeah, yeah. I think the other thing I personally have found interesting is kind of like these inductive charging roads or wireless charging roads.
Yeah.
Yeah, I think that's kind of interesting because if that is something that can be actually realized in practice, I think that'd be kind of interesting if you could be driving and charging at the same time.
Always charging,
right? These long, stretches of road. I think a lot of us based in Arizona maybe drive to California, for vacation or whatever. So it's just a long strip that we, just driving straight for a long period of time, and maybe that could help minimize the charging experience where you just continuously charge your vehicle, and when you get to your destination, you're not maybe necessarily topped off, but you've mitigated how much charge you need to charge at your end destination, right?
Considering that range anxiety is probably in the top 3, if you could eliminate that, that'd be a big deal.
Yeah, and I think that'll be a big undertaking. I mean, obviously, our infrastructure would have to be able to support that, right? And I found some articles that in Detroit, obviously where a lot of the development of vehicles are being done, there's some test areas that they're trying this out in practice to see, kind of work out all the bugs of that. So, but again, it's going to be like a bigger, daunting effort to get there, I think. But I think that'd be kind of the ultimate goal where we can kind of do that, or at least a path of improving charging experiences for customers.
Yeah, agreed. Okay, any final thoughts? We've been talking a lot about automotive. Are there other applications for gate drivers? Are there other areas where there's development still to be done?
Absolutely. I mean, silicon carbide has driven so much of the interest, especially in relations to EVs. And it's interesting, with silicon carbide, for example, it's capable of much higher voltages, but EVs are typically 400 to 800 volts. Right. And that's become the sweet spot for silicon carbide. And that's where I think everyone hears it in maybe in media publications and maybe more in our smaller industry colleagues. But that's really what's driven the interest of silicon carbide. But silicon carbide is used in many applications. You can think about data centers, for example.
Yeah.
As we get more AI computational power that's going to be required. Previously, there was a lot of crypto mining that would need a lot of power as well. Anywhere those companies can benefit from improving efficiency, silicon carbide comes into place, right? And so, again, you'll need a gate driver in that whole piece of the puzzle to realize that benefit. As we mentioned, we don't only offer for silicon carbide gate drivers, but we also have standard gate drivers as well. So anywhere where you're doing any kind of conversion, whether it's AC to AC, AC to DC, DC to DC type of applications, you'll find a gate driver is probably in there being utilized in the application. So.
Right, because our need for electricity is only going to go higher.
Exactly, yeah.
That was great, Jeff. Thanks a lot.
All right.
Glad to have you on. Jeff Garcia is a product line marketing manager at Microchip Technology. He specializes in power conversion solutions and associated technologies. He joins us today from our global headquarters in Chandler, Arizona. Thank you for venturing beyond the microchip with us. Join us next time as we continue to explore empowering innovation to enhance the human experience.